The table here shows you the lateral clearance adjustment factor, FLC. You will, according to the right shoulder lateral clearance width, this is the width of your lateral clearance, then if you have this number of lanes in each direction, then you have the reduction factors accordingly. For example, when your right shoulder is 0.6 meters, then, for example, you have a 4-lane highway in each direction. So your adjustment factor will become 1.3. For example, you don't have any shoulder clearance and you have a 3-lane highway in each direction. So you'll have to reduce your free flow speed by 3.9 kilometers per hour. Okay, and we are still in process number 2, determining the free flow speed. Now, what is the total ramp density? This is the number of on and off ramps per upstream or downstream. For example, you have a 10-kilometer highway, then you have to count how many ramps are there, and then you divide it by 10 kilometers. Now let's move on to the process number 3. We're ready to calculate the analysis flow rate of the freeway. And under this, we have to adjust the peak hour factor, the vehicle mix, and the driver population. And VP here is actually the flow rate. This is the flow rate. And we determine the flow rate by dividing the hourly volume of the freeway divided by the products of your peak hour factor, the number of lanes in one direction, the heavy vehicle adjustment factor, and then the driver population. Now, how can we determine the values of this one? The peak hour factor can be determined by dividing the hourly volume by the 15-minute volume within the hour of analysis. This is the maximum volume within the hour, and multiplied by 4. So that's the peak hour factor. We also need to take account the traffic mix. For example, you have passenger cars flying on the freeway, you have trucks and buses as well, and the recreational vehicles. So you have to convert them into passenger car equivalency. And also need to take account for the conditions of the grade. And PCs can be selected for one of the 3 conditions. So if you have specific upgrades, specific downgrades, and extended general freeway segments. In this chapter, we are covering only the level freeways. So we may not cover the freeways with upgrades and downgrades, but we will mention the tables that are used in determining the adjustment factors when you have specifics like this. For the extended general freeway segments, as a guideline, we usually use the terrain of the freeway classified as level or rolling terrain or mountainous terrain. And for the adjustment factor for heavy vehicles, for example, we have a level terrain, then we need the ET for trucks and buses, then we can use the value of 1.5. If you have the RVs, then you can use the 1.2, and so on. So we can use this table 7.4 in determining these values which we use in determining the heavy vehicle adjustment factor. So a level terrain is any combination of grades and horizontal or vertical alignment that permits heavy vehicles to maintain the speed as a passenger car, and this classification generally includes short grades of no more than 2%. How about for a rolling terrain? This is any combination of grades or vertical alignment that causes heavy vehicles to reduce their speeds below those of passenger cars. But this does not cause heavy vehicles to operate at cruise speeds for any significant. So this is classified as rolling terrain. And then we have the mountainous terrain. So this is also, it's any combination of grades, whether that's horizontal or vertical alignment, that causes heavy vehicles to operate at cruise speeds for significant distances or at frequent intervals, and this is classified as mountainous terrain. This table here shows you the PCEs for trucks and buses for specific upgrades. So you can use this when the analysis segment consists of terrain that cannot be considered as extended general segment. So you have the upgrade percent, the length of the segment in kilometers, and then depending on how many trucks do you have in the traffic stream. So for example, 10%, and you have greater or equal to 2 to 3% upgrade with the length of 1.5 kilometers, then you can use 1.5 when you have 10% of trucks and buses within your traffic stream. This table is used for PCs for RVs on specific upgrades, and this is for PCs for trucks and buses on specific downgrades. The heavy vehicle factor, FHV, is calculated using this formula that you can see here. It's 1 over 1 plus the PT, which is the proportion of trucks and buses in the traffic stream, multiplied by ET, the passenger car equivalency for trucks and buses, which can be found in table 7.4, minus 1 plus PR is the proportion of recreational vehicles in the traffic stream, multiplied by the passenger equivalency for recreational vehicles, minus 1. And ER can also be found in table 7.4. The driver population factor, FP, range from 1.0 to 0.85. In general, if in the problem it says that the commuter traffic is mostly familiar users, then 1.0 can be used, unless there is sufficient evidence or it is the analyst's judgment that a lesser value reflecting more recreational traffic characteristics should be applied. The next step is to calculate the density. Density is equal to flow rate over the average passenger car speed in kilometers per hour. Now, how do we determine the average passenger car speed? We'll discuss it later when we will go to the example problem. Now, this flow rate here has been calculated in the past using the indicated equation. And then after calculating the density, you can now determine the level of service of the freeway. You can use this chart, or you can use the table that I will be showing in the next slides. Okay, so what can you see in this chart? This chart shows the S in kilometers per hour, and this is the flow rate that you have calculated in step number 3. Now actually this chart, you can use it to determine the level of service if you already calculated the flow rate and you already identified the speed in kilometers per hour. And you can also use this table when you have calculated the density, which I've shown in the previous slide. For example, your density is equal to 11.2. So you can see this line, this broken line here shows the density at 11.2 passenger car per kilometer per lane. So this means that the level of service of the freeway is within the region of LOSB. How about if you have calculated a density, let's say 10 passenger car per kilometer per lane? If you look at this broken line, this is 6.8 and this is 11.2. So 10 is anywhere within this region. So the LOS is still B. So if the density calculated is 6.8 passenger car per kilometer per lane or less than that, then the LOS is at this region, A. The same is true with these regions of LOSC, LOSD, LOSE, and LOSF. Now, how do you use this chart when you have already calculated the flow rate and you have already identified S? For example, the calculated flow rate is 1,500. So you start from this point and draw a vertical line going up, which should intersect with the corresponding S here. So for example, your S is 104.6 kilometers per hour. Then the intersection of the line drawn here, okay, so you are drawing a line here, straight line, then it intersects at this point with S is equal to 104.6 kph. So the LOS of the freeway is within this region of LOSC, since this is the point of intersection. So the same is true with others. The point of intersection of the flow rate with the line drawn vertically upward and the corresponding S is the region where the LOSC or the level of service of freeway is shown. You can also use this table 7.8 in determining the level of service of a freeway. So you can notice here that there are information about the free flow speed here. So for example, your FFS is equal to 112.6 kilometers per hour, then you can use this section of the table here to determine the LOS. For the information that you need is the maximum density, the average speed, the maximum volume to capacity, and then the maximum flow rate. You can also use this table 7.1 in determining the level of service of a freeway. So if you have already calculated the density, then you can just look at this table, and wherever the calculated density is ranging, then that's the corresponding level of service of the freeway. So for example, you have calculated a density that's equal to 10 passenger car per kilometer per lane, then it's under this range, which means that the freeway has a level of service B. Now, let's look at one example of how to apply the formulas that we have discussed in determining the level of service of a highway.